I will get started. Today I have 4 demos. It's all about temperature sensor. Temperature, it turns out, is the most important sensor. So the first one I'm going to demo is this right here. It's a type K thermocouple. So type K thermocouple, if I look at the Google, I did the conversion. Type K can measure 1260 Celsius is equal to 2300 Fahrenheit. So 2300 degrees, it can measure very high temperature. So this is used as flame sensors. So I will use this, use a little flame. So on your furnace, the flame sensor can fail. I watched the YouTube videos. Those technicians said those the most likely problem for your furnace. Every winter, if your furnace cannot start, turned on and turned off, turned on and turned off, it's because the flame sensor doesn't work. Usually, it's a very easy fix. All you need to do is find the flame sensor, easy to find because it's right above the flames. That's where the flame sensors are. And usually, you just need a good cleaning. One technician says a dollar bill works good. Just use a dollar bill. It's made of $100 bill works better than dollar bill. So if you have $100 bill, yeah, just wipe it, make it clean, because that flame sensor will not have 100% output when there's covered with dirt and whatever accumulates on top of it. And your furnace is thinking your flame is not turned on, so your furnace will shut off after 2 or 3 seconds for safety. So flame sensor, that's exactly what it is in the furnace. So I will turn on this sensor. It will measure the temperature, and then I will put a flame onto it to see what is the temperature of my flame. So now it's so 75. Oh, it's upside down anyway. It's 77 degrees. So that is the measured temperature from this sensor. If I hold my hand, my body temperature, this temperature will go up, 78, 70. Notice it takes a couple seconds to respond, the response time, a couple seconds. So now it's 81, 82. So I'm good. I have no temperature problem, right? If I go all the way 100, I need to quarantine, locked up. So now I'm okay, 87 degrees. Now I will put the flame over there. Let's say the temperature goes up. This instrument only measures hundreds of degrees, so it cannot measure 2000 anyway. So it takes a while for that. So let's give you an idea. This sensor is tough, can measure higher temperatures. The other sensors will probably melt it. Well, I cannot hold it anymore. My hand is too hot. It's too hot over here. Anyway, this is our first sensor, type K. So thermocouple is an excellent sensor. It measures high temperatures very accurately, used on controls quite often, especially when you have a high pressure cooker. The second sensor we're going to demo is this guy right over here. Yeah, this sensor right over here. This is LM34. LM34. This sensor probably 50 cents, very inexpensive. So if you search LM34, it's a common sensor. That's the sensor Johnson Control used to control their battery charging process. So when they want to keep an eye on the temperature of the battery, that's the sensor they were using. That's the sensor. So let me share the little bit of document about the sensor. So that's the sensor, LM34. It's a precision. This one is a Fahrenheit, so the output is Fahrenheit. It's 10 milli per degree. So if the room temperature is 77, the output will be 77 multiplied 10. It will be 730 milli. So the output is analog voltage. It's a 10 milli per degree scale factor. It can measure all the way to 300. So cannot do 2000 like the thermocouple, but this one can do 300. So at 300, the output will be 300 multiplied this will be 3000, right? 3000 milli. That will be the output. So this is the sensor, only 3 wires, 3 connectors. So that's the sensor, input, ground, and output voltage. So this is the temperature. Very simple sensor. Very simple sensor. They did a 3-wire sensor. So this is called a 3-wire. But at Johnson Control, they converted into 2-wire sensor. So this is how we converted into 2-wire sensor. So that's a 3-wire sensor, and with 1 resistor. In this case, they use 500. By adding a 500 resistor, the 3-wire sensor is converted to a 2-wire sensor. So that's the 2-wire twisted pair. This is inside the controller. So this circuit is inside controller. So that's a 2-wire sensor. That's exactly what the Johnson Control sensors are. They have a 2-wire sensor. So this wire can be 100 feet. This is a long wire. So they make a twisted pair, reduce the noise. And of course, they pay $30 for it because they use a stainless steel jacket protecting the sensor. So the sensor will not be damaged by chemicals inside the battery. So let's do a demo. I will connect this to my power supply, and let's see what happens. And then measure the output temperature, output voltage. The output voltage will be the temperature. table. Oh, I will hook up the power. That's what I was. I will share my instrument so you guys can see what I'm doing on my instrument. So power supply, I will give a 5 input power. I will turn it on. So once I turn the power supply on, it will provide 5 to the sensor. And then I will go to the meter. I will turn on the meter. So you see the output is a 70 milli. That means my room temperature right now is 70 Fahrenheit. So that's the temperature reading, 704. So the room temperature will be 70.4, 70.5 right now, Fahrenheit, 70 milli. So that's our second sensor. If I put my hand, I cover the sensor with my hand, it will go up. So this one go up pretty quickly, 75, 6, 7. So that's pretty sensitive, very sensitive. The response time, it's still, you have to wait like 10 seconds, 20 seconds, or even 1 minute to stabilize. Because my body temperature is probably 90 degrees, is that right? Body temperature? Normal person?
About 97.
97? Oh, looks like I have a cold hand. So I warmed it up to 80 degrees, not all the way 97, but so that's our second sensor. So this one is also very popular because the output is straightforward. It's a 10 milli per degree, so very easy to interpret the temperature. Of course, if you need a controller, you need to get a couple of amplifiers to recondition it, for example, to 0 to 5, whatever you wanted the output to be. So that's the second demo. It's a solid state. So this sensor is a solid state. It's a transistor. So the transistor will measure the temperature. The next one is also solid state. Next one is this guy right here. I have it over here. Let me turn off this. All right, let me get this, put it apart, and the next one will be this chip right here. This chip is called, I forgot what it's called. DS162, 1620. Yeah, DS1620. So the part number for this chip is DS1620. So let's find some information about this particular chip. Let's Google it. Okay. So right now I'm sharing my output, my Google results. So DS1620 is a digital thermometer plus thermostat. So this is a pretty powerful chip. It can control air conditioner plus heater. So you have one control to control both the heater and the cooling and the heating. So I actually always think if you build a cat house outside for my cat, so my cat can have a nice, comfortable place in the summer and in the winter. That chip will be perfect, this particular chip, DS1620. Right now, if you look at my circuit, I'm using a green diode simulate air conditioning unit. And the red one simulate a heater. So I will program this chip. So this chip need to be programmed by a computer. So the programming is done by those three wires. We have 1, 2, 3 wire over here. That is the programming. So this chip will talk to my computer, and my computer will set the upper and lower temperature. So if it's above the upper temperature, turn on the AC. If it's below the lower temperature, turn on the heater. So this chip will regulate the temperature between the upper and the lower. So that's the comfort zone. So for example, if I build a cat house, I will probably put it like 50 to 80 degree, right? 50 to 80 degree, that's good enough for a cat. 50 in winter, 80 degree in summer, right? So I will show you the code. Once this chip is programmed, you can disconnect those three wires, and this chip can work by itself. So it only need to be programmed once, or anytime you want to change the temperature. So once it's programmed, you can disconnect those three wires. It will work by itself. So let's me first show you the code. I connected my computer to my laptop through this USB. So now I will show you the source code on my laptop, and then I will download my code to this little computer, and then this little computer will program my chip. So that's what I'm going to do. So first I will start this that's not the code. Let me find the code. All right, okay, I found the code. Let me show the windows to you guys. So the program I'm showing you right here is the program I will download to my computer. And this program will download to the computer and run on this little computer. When this program runs on my little computer, it will program the chip. The only thing I need to change is here, the upper limit and lower limit. So for example, 70, not 70, let's change it to 77. So if it's below 77, I want to turn on the heater. It is above 80, I will turn on the air conditioner. So that's the comfort zone, 77 to 80 degrees. So now I will program my chip, program my computer, download my code to my computer. So let's download. Perfect, perfect. So right now it's 75. So what happens? Turn on the heater. You see, my red LED is turned on because my code says if it's below 77. Did you see the red is on? Yeah, the red is on.
So the red LED is
a heater.
A heater?
Yes, heater. So because it's a 75 right now, so the heater is on. So if I warm up my chip, that means the heater is on. I warm up my chip up to 77. Now the heater is off. Heater is off. Now if it's below 77, the heater will turn back on again. You see, that's below 77. Heater will turn on. So this is the heater. And then if I keep warming it up above 80 degrees, the air conditioner will turn on. Right now it's at 78, 79, 90, 80 degrees. Now the air conditioner is turned on, right? The blue one is on. So now it's in the cooling mode. Cooling mode. So this little trick, okay. I said after the program, we do not need those 3 wires. So I will disconnect the 3 wires. I will pull the 3 wires out. It will still work. So when the temperature drops below 80, this air conditioner will turn off. Air conditioner will turn off. When it's how can we make it faster? Don't know. Something cold. So right now it's still too warm. The air conditioner is still turned on. So the cooling takes some time. Anyway, once this is programmed, it will work like this. So right now, because this is over 80 degrees, the AC is on. Let's wait a couple of seconds for the AC. Oh, now it's turned off, right? No, it's still on. It's still turned on. The AC is still on. So why is it still on? Should be off now, right?
Must stick it in your refrigerator.
Still on. We got a problem. Not sure why it's still on. Should it be off already? Let me disconnect the battery. Now it's off. I don't know what's. So now it's in the comfort zone, I think. So if I warm it up, it will turn on the AC. Now I do not have feedback because I disconnect from my computer. I do not know the temperature right now. So I'm just guessing why this is not working.
I think you have to run the program again.
No, you don't have to. Once it's programmed, it's standalone. That's what it was designed. It only needs power. But so let me anyway, let's move on. So it's supposed to be standalone. So once it's programmed, it should work. So the low temperature will be 77. The high temperature will be 80. And but since it doesn't work right now, so that is our second, the third demo. Let me reprogram it. Okay, let me get those 3 jumpers. So I will rewire my computer. So let's see what's going on. I forgot how to rewire those 3. Anyway, let's move on. I don't waste our time. So this is the third one. Okay, let's move on. The next one will be the wireless sensor. So in many applications, the temperature sensor we want to measure is a remote or mobile. One of our students works in a truck company. They build those big trucks. Big trucks carry melted chocolate. So they need to keep that chocolate at a certain temperature. And that's mobile application. That truck is moving. So they need a wireless temperature sensor. So for wireless temperature sensor, there's the industrial standard. The industrial standard is this. This is a wireless transceiver. It's called the Zigbee. Zigbee. This is the older version called the XB, the upgraded version called the Zigbee. And this is a industrial standard RF transceiver. So it can send the signal it can receive signal. So I will have two. I forgot which is which. One will be transmitter. One will be the receiver. So one will be the receiver. So I would assume this is the transmitter. So this guy will send out the temperatures. What about the range? The range, they have a low power mode and a high power mode. In low power mode, the range is kind of like a Wi-Fi, 100 yards, 100. In high power mode, it can go a mile, 1 mile maybe, or it can be pretty long distance. So your sensor can be a mile away, and you still can get the temperature through this RF module. So right now, my transmitter is started flashing. That means it's sending out videos with temperature information. And now this is the receiver. I will connect it to my laptop, so I can read the temperatures on my laptop. So in order to receive temperature on my laptop, I need to. Okay, now I got it. 37 degree, 73 degree. So now my receiver got the temperature, remote temperature. Did you see my share screen? Let me share. So now the remote temperature is 37 degree. So this 73 degree came from this RF receiver. The RF receiver received it. It sent over to my computer. My computer, you see it flashing, the LED flashing. Transfer that data to my computer, and then it's put it on my monitor right here. So yes.
How fast is it transferring that information?
It's not very fast. The Zigbee is for sensors, so we are not talking about megabytes or gigabytes. We're talking about thousands. It can transfer a couple thousand bytes per second, which is fast enough for industrial control situation. We want to monitor whatever, within seconds or milliseconds. So a few thousand times, or a couple hundred times every second. Not very fast. Yes, a very good question. Anybody have questions? This remote sensor is the identical sensor one of the graduates used in his truck. It is also the same sensor green manufacturer, our local company. They have a battery-powered car jack. So the mechanic use a battery-powered jack to jack up the cars, actually big trucks, for repair. They usually put a 4 on 4 corner, and the 4 will go up and down simultaneously because every battery-powered jack has a XB module. So they actually talk to each other. Say I'm 1 foot tall, so the other will all be 1 foot, synchronized. All right, that's all I have for today. We have 4. The last one will be a remote sensor. So any comments? Anybody wants to have questions before we end the recording?
So how exactly does the system there work from the program, from you telling it, it needs to stay at this temperature, or how do I?
It just measures the temperature. There's no control right now.
So you're. Oh yeah, that's right. You're just measuring now.
Yeah, the control will be the next step. Once we know the temperature, we might make a decision to warm it up. The chocolate, for example, need to be hold 100 degrees. I don't know what temperature is good for chocolate when they're shaping the chocolate. So if the temperature is 70, obviously it's too cold, then they will turn on the heater to warm up the tank. Yeah, right now it just measure.
Okay. I think this would make more sense if I saw it in person.
Yes, always better to, you can, this is a, yeah, the video helps, but the real component will be much better. Each of those costs about $10. So those are standard module. You just can buy one of those and connect it to your computer.
Are there pieces like, oh, I'm sorry, what?
Both sides have to be a computer. So on the sensor side, it will be a computer. The receiving side also needs to be a computer. The good news is the computer only costs $1 a piece. So the computers are pretty inexpensive. Yeah.
Is there equipment like this in the lab in Wilson right now?
No, we don't have this in Wilson. These electronics devices are inexpensive, but it's very small. And so, yeah, we can stock some in our electronics lab, but right now we don't have a stockpile of those.
Okay.
Yeah, the good thing about electronics is everything is dirt cheap, inexpensive. Yeah, a computer costs $1. Unbelievable.
That is pretty cheap.
Yes. You cannot even buy a hamburger. You need $5. All right. Anything else?
That's all I can think of to ask right now. Thank you.
Thank you, Craig.
Is there an assignment for today or to turn in?
Assignment. I'm still working on this PID controller. I get pretty good progress. So today there's no assignment. I got pretty good progress. I can show you the 60 watts light bulb works perfectly as a heater. I just did that. I was worried about the 60 watts light bulb, but it turned out if you use a laptop power supply, the output is 20 watts DC, and use that 20 watts DC connect to a 60 watts light bulb. The 60 watt light bulb works perfectly as a heater. It warms up really quickly, nicely, and safe. Most important is safe. So the next step, I will put that light bulb in a box, whatever box you have. And then we can have a closed environment. We can do a PID control. So everybody will probably need to spend about $30, $40 to buy stuff if you don't have already. The controller will be $25. That's good news. Actually, that is extremely inexpensive. If you buy Joe, do you know how much industrial PID controller cost? If not thousand,
I'd have to look them up.
yeah, if
I
not
was
thousand,
wondering if I could just. Well, yeah, I don't know. Ours are a little different
if not
because
thousand,
our stuff's all PLC.
yeah, if not thousand, it will be tens of thousands. In our lab, we have one PID controller. We bought it many years ago from Europe. PID controller, a lot of fancy. It's the PID is all done by computer. Actually, it's not the PID controller hardware. The PID controller, $100,000. My goodness, it's a simulate a small plant, small chemical plant. But again, $100,000.
I'm wondering if I wouldn't be better off just getting a PID that does 120 AC because I've already got a heating element and everything set up in a cat house outside.
Perfect. Oh,
And,
yes. Joe, you can do it.
then-
The rest of the people cannot do. Need to be. I trust you, Joe. You're good. Do you have a license, electrician license?
Absolutely not.
Absolutely not.
But
Then
I've rewired my
then
house. and
probably
it
I
has-
will reconsider. Anyway, yeah, 110 is much better because it became a real useful device. Yes. But if you use 110,
Because I mean, I've already got it set up.
but 110, if you use
Yeah,
120, the light bulb will not work. The light bulb only works
Right. I
with
have a.
small heater. Yeah.
Oh no, I have a. What do they call a?
Space
It's a
warmer.
heating element that screws into. No, it's a heating element that screws into a light bulb socket.
Oh wow, yeah, that's good. That's good. Yeah.
Yeah, it's an
That will
infrared.
work. That will work. Because
Yeah.
the reason I think not working is because this controller will turn the light bulb on and off every 10 seconds or every 20 seconds. If you have a real light bulb in 120, you are like a little kid turn off the lights on and off repeatedly every 20 seconds. It will not last very long.
I see.
Yeah, that's not what your mom used to tell you not to do.
Okay.
But for 20 watts DC, it's okay. 20 watt DC is okay. We can turn it on and off. It just make it warm, not the I measured the resistance of the light bulb. It's a 15 ohms when it's cold. It's 150 ohms when it's completely turned on and hot. So when it's cold, it's 15 ohm.
Okay.
So the light bulb can be used as a temperature sensor, right? So.
Yeah.
Because the resistance goes
Yeah.
from 15 to 150 when temperature goes from 0 to maybe 1,000 degrees. Yeah, it's a temperature sensor. All right, anything else before we turn off the recording? And I will see you guys next week for the class.